All right, I think this is recording. Let's take a look at these two problems. These are compound inequalities. Um, we're going to discuss the difference between and or in mathematics in these inequalities. So let's start with number 5 over here. We want to work on these two inequalities separately. Make sure that you copy it down right. So here I have this inequality. Let's take away 5n from each side. 6n minus 5n is just n. And let's take away 7 from each side. And we see immediately that we have our solution that, well, I'll sketch that in just a minute, that n is less than, strictly less than, negative 15. So now we have this or. We have this inequality, 8n minus 6 greater than or equal to 5n plus 9. Let's subtract 5n from each side. Let's add 6 to each side. Divide each side by a positive 3. All right, and now let's make a quick sketch of this on the number line. Negative 15, say, is here, and which would make negative 16 and negative 14 the integers that surround that. Since it's a strict inequality, negative 15 is not in the solution. N is less than that, so we shade all the numbers to the left. So any value in here is going to satisfy this left inequality, or if we're bigger than 5, they want values that will satisfy this one or the other one, or in some cases it would be both if you had both of them had the entire real number line as the solution set. Or if they overlapped. Here, I want to include 5 in the solution set because it's not a strict inequality. It's greater than or equal to. So we include 5 by indicating a solid dot on our sketch, on our graph of the number line, and we shade to the right. They want us to express our final answer using interval notation. On the left here, this arrow is shaded. That's indicating negative infinity. All the way up to the right here at negative 15. Negative 15 is excluded from the solution set, so it's an open parenthesis. Then over here, we've got 5. It's included. It's a solid dot, so we have a bracket there. And that right arrow is shaded, so that indicates it's going all the way out to infinity. So remember that it was or. Either the value of n is in this shaded region or it's in this shaded region, and those values of n will satisfy one or both of these inequalities. The mathematical symbol for or looks like a big U, and it's even called a union, and it's the union of these two sets. It means that you're a member of this interval or of this set, or you're a member of this set. All right, so let's take a look now at number 6 because that's our final answer there, this interval notation for number 5. Here we have a different kind of compound inequality. It's going to be separated by the word and. You'll notice that there's 3 parts to this one, and when you have a variable in each part, you're going to have to separate these into 2 inequalities. If you only had the variable in the middle portion here, you could get away with working in all 3 parts and trying to balance it just like you would an equation. But here, we're going to have to separate because we're not going to be able to get that v by itself in the middle without doing that. So in the left here, we've got 6v minus 6 is less than 8v plus 10. And instead of the word or, we have and. And this inequality, the middle one, 8v plus 10, is strictly less than this 3v minus 5. So we solve these two inequalities separately, but then when we sketch it on the number line, we look at the intersection of the two sets. A member of the set here that belongs to this set also at the same time has to belong to the other one to be in the solution set. All right, so to solve this for v, let's take away 6v from each side. Let's take away 10 from each side. I like to write my variable on the left-hand side. You don't have to do that, but by doing that, the direction of the arrow will help me in which direction to shade on the number line. I kind of use it as a check. Divide each side by a positive 2, and values that are strictly greater than -8 will satisfy this inequality. But that's not our final answer. We have to come over and take a look at this other inequality. Let's subtract 3v from each side. And let's subtract 10 from each side. Now remember that subtracting 10 is not going to change the direction of the arrow. It's only if you multiply or divide by a negative number. Like here, when I divide by positive 5, even though this 15 is negative, when I divide by positive 5, that arrow stays in the same direction. -15 divided by a positive 5 is -3. So let's take a look at what we have here. Now, I normally don't draw all the tick marks to the next one, but the distance between the -5, -8, and -3 is so close that it's only going to take a second to include these intermediate values. All right, so I want to be greater than -8. Well, that means that -8 is not included in my solution set, and greater than -8 means all values to the right of -8. But at the same time, simultaneously, I want to be less than -3. Okay, so when you look at all the values that are greater than -8, that excludes all the way to infinity. When you look at all the values that are less than -3, that indicates all the way to negative infinity. It's only this overlap that the part that's in both sets do we shade that we're interested in. So we're only interested in the value in the numbers that are strictly greater than -8 and at the same time strictly less than -3. They want us to write this using interval notation because that's a picture of our solution set right there. So that we always write smaller number comma larger number in interval notation. So at -8, that's our smaller number. At -3, that's our larger number. And the endpoints are excluded, so we have open parentheses on each end. Pick any number that's in this solution set that's bigger than -8, smaller than -3, and you'll find that this original inequality will hold true, or that separately these two will both be true at the same time. Pick values that are outside of there, and one of them may be satisfied, but the other one won't be, or vice versa. Or maybe in some situations you could have where neither one of them would be satisfied. Although maybe I take that back. Maybe that wouldn't work unless some real odd or extreme case. All right. Hey, I hope that helps, and I will talk to you later.